So what is the permittivity of a medium? We had got an equation. F is equal to K. This is the Coulomb's law, right? So we know this force, the electrostatic force is medium dependent. K is equal to 1 upon 4 pi epsilon, right? So this is known as the permittivity of the medium, right? So what do you mean by permittivity? So as you know, the permittivity, it means what? Permittivity means allows. So what is it allowing?
Electric field to pass through a medium.
So it is allowing its own field. Yeah, it's allowing its own field to suppress the interaction field between two charges. Let us suppose this is Q1, Q2, right? There must be some forces between Q1 and Q2. So due to that, there is an electric field. Now, if you, this is in vacuum. Now, if you take the whole thing and you place it in a medium, so what the field of the medium will oppose this field of between the two charges. So here permittivity of the medium is like it's allowing its own field to decrease the interaction field between the 2 point charges, right? So what do you find? Permittivity in free space, or you can say it is in vacuum. What is it? What's its value? Vacuum, free space, air, that is given by epsilon naught. So yeah, 8.85 into 10 to the power minus 12, right? So this is very less, right? So permittivity in air, free space, or vacuum is very less. And if in a medium we take, this is the permittivity of medium, epsilon m I have written, that is much greater than epsilon naught, right? So this is a very important formula, that is permittivity of a medium is greater than epsilon naught. So what happens to the force of a when it is kept in a medium charges and when it is kept in a air vacuum or free space? So you find the force when you keep electrostatic force between these two charges when you have kept in a medium, then the force decreases, right? So this is also a very important relation. Like sometimes they might ask you objective type question. Then what is the relative permittivity? Epsilon r. So that is the permittivity of the medium upon the epsilon naught, right? So if let us suppose you can write this as EM is equal to epsilon r epsilon naught, right? So permittivity of a medium and relative permittivity and epsilon naught is given by this relation. So if I say epsilon r of, let us suppose, of water is 7, then you can calculate the permittivity of that water. What it will be? 7 times E naught. You know the value of E naught, right? So this relation is also important. Then another thing is that if you know, let us suppose we know the force in a vacuum or free space is given by 1 upon 4 pi epsilon naught, right? Q1, Q2 upon R square. This is in force in free space, or you can say in vacuum. Free space, vacuum, or sometimes we also say assume air, all as epsilon naught. And if this is Fm, that is in a medium, then it is 4 pi epsilon m Q1, Q2 upon R square. Now, if I ask, I haven't changed the distance. The distance is same and the same charge I have kept in a medium. So I've got these two equations. Now I ask you find the ratio of F naught upon Fm. So what you will get?
EM upon E.
Yeah, that is equal to the relative permittivity. So if you know the relative permittivity, you can also calculate the, and one of the force F naught, then you can calculate Fm also. Fm is equal to F naught upon epsilon. So this is also an important relation.